Welcome to True Projects. In this video, we are going to explain about a project titled Emotion Detection using Machine and Deep Learning. Emotion detection is an intriguing project that centers on the machine and the deep learning algorithm capacity to identify and decipher the human emotion from the diverse channel like text. The comprehension of the human emotion holds the substantial relevance across the domain such as healthcare, education, customer service, and the human computer interaction. Through the utilization of the machine and the deep learning methodologies, we have the potential to revolutionize the manner in which the machines engage with humans. This transformation translates into the interaction characterized by empathy and the tailored experience, accentuating the symbolic relationship between the technology and the human emotions, and ultimately fostering the more meaningful and the resonant connection. The primary objective of this research is a goal to construct a robust and precise emotion detection system employing the machine and the deep methodologies. This encompasses of elevating the accuracy and efficiency by harnessing the advanced machine and the deep learning algorithms with a drive to transcend the conventional technique and establish a cutting-edge benchmark for discerning the emotion from the varied inputs. Augmenting the human-computer interaction will imbue the machine with ability to grasp and respond to the human emotions, nurturing the interaction, brimming with the empathy and the resonance, and exploring the tangible application. This extends to uncovering and showcasing the emotion detection tangible utilities in arenas like mental health diagnosis, customer sentiment analysis, and the virtual assistants and the adaptive learning system. And these are the basic requirements that are needed to build this project. The software requirements are Python IDE with version of 3.7, Anaconda with version of 3.7, or Jupyter Notebook. Hardware requirements are operating system as Windows, processor of minimum Intel i3 and above, RAM of minimum 4 GB, hard disk of minimum 250 GB. And to know about the flow of the project, these are the steps we need to discuss. The first one is importing the packages. In this stage, essential Python libraries are imported such as Pandas, sklearn for data manipulation, and the TensorFlow or PyTorch for the building and machine learning, deep learning model. And the second one is loading the dataset. Here, the load dataset containing the emotional data is loaded into this memory. This data could include the text annotated with the corresponding emotions within it. And the next one is data processing. Addressing the issues like missing the value and normalization. This step ensures the dataset is conducive to effect the analysis and the model training. And the next step is visualization using the Seaborn and the Matplotlib. Seaborn and the Matplotlib libraries are utilized to visualize the data distribution and the relationship. Visualization aids in understanding the distribution of emotions and the pattern in the dataset. And the next one is tokenization. For the text-based input, tokenization is applied to convert the words or the sentence into the numerical tokens. This numerical representation facilitates the model training. And the next one is feature selection. Features relevant to the emotion detection are selected while irrelevant ones are discarded. Feature selection optimizes the model performance by focusing on the important attribute. And the next step is splitting the data to the train and the test. The dataset is divided into the training and the testing subset. This separation allows for the model assessment on the unseen data, causing its ability to generalize. And the next step is building the model. Here various models are built. The first one is logistic regression. It establishes a basic approach for the emotion detection, modeling the probability of the emotion class based on the input feature. It serves as a starting point for causing more advanced model performance. And the next one is random forest. It employs an ensemble of decision tree to aggregate the prediction, enhancing the emotion detection accuracy. This approach captures the intricate pattern in the emotion by mitigating the overfitting and handling the non-linear relationship in the data. And the next one is decision tree classifier. It splits the data into the subsets based on the features, providing a straightforward and effective method for recognizing the complex emotional cues. It contributes to identify the intricate relationship within the input data. And the next one is KNN. It relies on proximity-based classification, predicting the emotion based on the similarity in the feature space. It excels when instances with alike characteristics exhibit the similar emotional attribute, enriching the emotional detection accuracy. And the next one is XGBoost classifier. It harnesses the gradient boosting to iteratively refine the classification accuracy. By combining the weak learner into a robust model, it improves the emotion detection by concentrating on the misclassified instance and enhancing the overall classification. And the next one is voting classifier. It combines the logistic regression, random forest, and decision tree models. This ensemble method capitalizes on varied perspective, delivering the method enhanced emotion detection accuracy through the collaborative decision making. And the next one is LSTM. It stands for Long Short Term Memory, specializes in understanding the sequential data like speech. It captures the temporal pattern in the input, enriching the emotion detection by comprehending the context across the time, yielding more nuanced and accurate result. And the next one is user gives the input. User provides the input as a form of test with the help of the Flask as a web interface containing the emotional context they want to analyze. And the next step is given input is translated and pre-processed for prediction. The provided user input is translated into a format compatible with the model. For test, this involves tokenization and the modality appropriate processing is applied. And the next step is trained model is used for the prediction. The pre-processed user input is fed into the trained model where each model utilizes its pattern to predict the emotion associated with the input. And the last one is final outcome is displayed. The prediction from the models are consolidated and presented as a final outcome. Users receive the information regarding the predicted emotion, enhancing the understanding of the emotional context within the provided input. And the execution of the project. To execute the project, first we need to open the code folder. And this is the code folder containing of various files within it. The dataset folder containing of the dataset that is used for testing and training of the data, and the static folder containing of the folders like SS, CSS, JavaScript, and images folders within it. And the template folder containing of the various HTML documents. It typically include of home and text result sign in and sign up pages within it. And the app is an py file which likely contain the information related to the front-end project. It includes the code written in Python that handle the server-side operations such as processing the user request, interacting with the database, and generating the dynamic content that to be rendered in the HTML template. And the notebook is an IPYNB file which contains the combination of code, graph, and output all in one place. It allows the user to write and execute the code in the individual cell, making it a popular choice for the data science. And the signup.db as a file appears to be the database file used to store the user information. And for the execution of the project, first we need to copy this code folder path and then open the Anaconda prompt. Here we need to write a command cd space and paste this code folder path. By this, it will change the current directory to the code folder path, and then click on the enter button. After this, we need to write a command that is python space app.py. By using this command, it will execute the Python script and perform the runtime check for any syntax errors or logical issues. And then click on the enter button. After running this app.py file, the Flask framework will host the application locally at the default address like this. We need to copy this link and paste it on any of the web browser of our choice, and I prefer to use the Google Chrome. I'm pasting this link and then click on the enter button. After running this, we get an of file home where it contains the information and the title of the project. Then click on the sign up button. It will redirect to the sign up page containing of some information that I need to be filled to create an account. But my account is already created, that's why I'm using the sign in button. Here it will redirect to the sign in page containing of username and password, and click on register button. Then it redirected to this page containing of the dialog box. Here we need to enter the test. Based on the test, it will classify the emotion. And here I am entering the message as I love my okay of red and yellow tulips and my arm feeling slightly more optimistic than when I arrived. Click on the Predict button. Here the test is classified with the emotion as of joy. By clicking on the Home button, we can re-enter the other message here. I'm entering the message of test as I don't feel particularly agitated. And then click on the Predict button. Here the test is predicted and classified as anger. And by clicking on the Home button, we can re-enter the other test as of I never make her separate from me because I don't ever want her to feel like I am ashamed with her. And then click on the Predict button. Here the test is classified as sadness. In this way, we can classify the detection of emotion by using the test with the help of machine and the deep learning algorithms. And in conclusion, the project has shown the immense potential of the machine and the deep learning and domain of emotion detection by employing the advanced algorithms and the extensive training on the diverse data set. We have achieved the significant advancement in accurately recognizing and classifying the human emotion. This technology holds the promise in revolutionizing the various industries, paving the way for emotionally intelligent mission and the application. Through the development of this emotion detection system, we have made strides in improving the human-computer interaction, enabling the mission to be more responsive to the human emotional cues. The application of this technology are vast, from the personalized mental health support to improving the customer experience in the business. As with the evolving field, there are still challenges to overcome, such as handling the cultural nuances and ethical considerations related to the emotion data privacy. However, the progress made in this project serves as a strong foundation for the future research and the advancement in the emotion detection using the machine and the deep learning.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.